we're going to do a quick one today here. I'm 737 captain, airline captain. I'm going to take you through what it's like to set up a 737 for a flight. A lot of different switches and buttons we got to look at. A lot of different things we got to push. If you are a flight simmer and you have a virtual reality headset, head on over to Flying for Money in 3D, and I'm going to have this in 3D, so you'll be able to watch this in 3D. Otherwise, if you don't, you're in the right place. We're going to hop right into it and show you what it's like to get a 737 set up rapidly for a flight. Right now, the aircraft is in the configuration, what we call the cold, dark configuration, which means that obviously no power is applied to it. You can see on the screens here, they're all blank. There's no power currently to any of the buses, the electrical buses in the system. We do have external ground power. So external ground power, you can see right here, it's lit up, which means that we have external ground power when we want it. But we're going to start off. So you get aboard the aircraft. We're going to go ahead and flip the battery on. This battery right here. Turn that on, get a little bit of electricity to the aircraft. We're going to verify the windshield wipers are parked, that the electric hydraulic pumps are not on. We're going to come down from there. I'm going to verify that landing gear is down, selected down, 3 green. We don't want that retracting on us when we supply power to the aircraft. And then we'll go ahead and there you go. GPU is supplying power, gets rid of a lot of lights, a lot of electric lights here that were on before have all extinguished. And then we have power to the aircraft. So then we're going to go to the overhead panel. We're going to make sure that the IRUs are switched on, so that you can start getting navigational information, GPS information. Once we've done that, sometimes we'll do this before that. We'll look at the equipment aboard the aircraft. So we've got a fire extinguisher here. Behind both seats, we have flotation devices. And then we have a PBE that's behind the first officer's right-hand side. PBE stands for Protective Breathing Equipment. It is a device you can put over your head. It's got an oxygen canister in it if you got to go fight a fire with that fire extinguisher. So they're always located next to the fire extinguishers. And then on the floor back here, we have a manual gear extension access compartment. It's right there. And I got to make sure that's closed or else the gear won't retract. Then we're going to check, make sure that we have all the equipment and documents that we need on board. There's some books that we need to have on board. And then equipment, another document we'd have is a quick reference checklist in case we have any fires or need to evacuate or do anything like that. We have access to that. And then we're going to hop into the overhead above us. We're going to check, make sure no lights are on. So back here, we have the leading edge devices, flaps devices, all those lights are out. We would have a lining here if we just turned on the IRSs. Show us that it's aligning. We'd have this switch here, would be in the off position, and that's just for the ground service bus. So if there's a mechanic in the back of the aircraft and he wants to be hooked up to the interphone, he can. So that's off. Doesn't make any noise. Overhead dome lights as desired. This is the second or the third auxiliary panel for a potential jump seater. That's a jump seat right there where someone can sit in up front if they want. They have their own aux panel. We don't need to do anything with that. All the lights extinguished except these 2 lights here, which are the ECs represent that they're on. Then we have oxygen O2, so 850 or above is good for 3 occupants for oxygen. Anything below that, then we'd have to look in the book, and it's a temperature chart that tells us what the temperature is, what the pressure needs to be for different temperatures. We have to look in the book and make sure we're good, or get a refill, or potentially not allow a jump seater on board. We got a few options there. 3 green, that's just a repeater for the landing gear. So 3 green is good. So all these switches are going to be in the guarded position pretty much at this point. This light over here is for the flight data recorder. And that's going to be off until we start the engine, so it's an amber light indicating off. That's normal. Push a button here. We're going to get in the aircraft. We're going to get some sounds, and then we get the stick shakers. We'll push that, and then the various stick shakers will actually shake and let us know that the stick shaker system is working. The other one was overspeed. So the other buttons test the overspeed system so we can verify that we have oral speed alert. After the overhead, we're going to come down. We're going to check oil quantity on the engines, and then the system here is hydraulic. These pages are actually a little bit different from the pages in the 800s for the airline I work for, but we check hydraulic quantity, check oil quantity in those pages, and that's that. Make sure the parking brake is set. We'll go and get that set there, and then we'll come back. And again, if we haven't checked the documents, we would check the documents, and then we'd go on to our before flight stuff. It's going to be on the overhead compartment up here, and so we pretty much take it sort of panel segment by panel segment. So we're going to start here, move down, start here, move down, come over here, move down. We're going to look at everything. Look down over here, look down over here, and then we're going to come across here and then look at all this stuff. Come down here and look at all this stuff. So quite a bit of stuff to look at. We got to get through it fairly quickly, though, when we're out there flying. Don't miss anything, but get it done fairly quickly because they turn these aircraft fairly quick. All right, so we have, again, all the guarded switches are going to be guarded. Got low pressure for the flight controls. That's because we don't have any hydraulics at this point, so that's normal. Yaw dampers off at this point. That's normal. Speed trim fail, these are abnormal. They're actually associated with the fact that we have not initialized our position. We'll do that in the box later. So those are up for now. These switches here are all in the normal position, which will be the centered position, and then auto for the display, so you can just look at that real quick. These are the fuel valves, so right now the engine valve is closed, the spar valves are closed, so all the fuel valves are closed. That's normal. These lights are extinguished. Center fuel pumps are extinguished. These lights actually only illuminate in the event that the switch is on and there's low pressure, otherwise they're extinguished. These fuel pump for the main fuel pumps are, they illuminate if there's low pressure at the pump, regardless of the switch position, because a low pressure in a main pump is an abnormal condition, even if you have it selected off on the switch. Whereas the centers, if we have it off in flight, that's a normal position, so the lights don't illuminate. If we have it on, that's a normal position. They don't illuminate unless it's low pressure. So that's what we're looking at there. I'll come up the top. This is the electrical panel. We can look through the different electrical sources. We can click through to see the different electrical sources, see if there's any load on it with amps. If we have any questions about that, generally just skip by that if you don't have any questions. Batteries in the guarded position, galley electricity is turned on. We got 2 drive lights for the generators. Those are illuminated because the engines are not turning, so the generators aren't turning. And then everything's guarded. Ground power is available. It's connected. We have the 2 gen off buses. Once again, the generators for the engines are not turning, so the gens are off bus. Then that's a normal indication there. Coming down, this is the APU, auxiliary power unit, EGT, exhaust gas temperature gauge. APU is off, so 0 is a good indication there. I'll turn that on here in a minute. Wipers are both in the park position. Come up across, these are cockpit lights. We can set them as desired. Equipment cooling is going to be in the normal position, both those switches. Emergency lights are for the passengers are in the guarded position. And then seatbelt sign at this point would be, well, that's auto, but it would be off. It's kind of hard to set these switches here, but we'll just leave it there. We'll leave it on. You'd normally be off here. And then we're going to come up here. We're going to turn on the windshield heat, and we're going to get 4 lights across the top. So those are on. We're going to leave the probe heat off until we're ready to depart. So all those lights are illuminated, indicating that none of the probes are heated, which is fine for now. We have wing anti-ice and the engine ice switches. They're both off. No annunciator lights associated with them. All of the hydraulics, so the engine hydraulics are on, but there's no pressure, so they show low pressure. And then the electric hydraulic pumps are off right now, and so they show no pressure. So 3 or 4 low pressure lights, that's normal there. This is the doors, so we got some doors open in the back of the aircraft. That's normal forward entry, and then cargo doors. The cockpit voice recorder, we're going to push the test button, get a green light there, just like that. Come up here, we can set as desired. That's the temperature coming out of the AC system. Right now, we don't have a bleed source for the PAC system aboard the aircraft. That's pneumatic air conditioning kit. We don't have a bleed source for that off the engines or the APU. So this isn't doing anything. But if it was on and we want to change temperature, we could do that there. I got a couple lights here that are indicating that the ram air doors are full open, which they should be on the ground, so that's normal. This panel here is we're going to have recirc fans on. Right here, the packs in my airline would be off. Again, it's kind of hard in here to do it, but these are an auto, which is fine. Isolation valves open, which means if you have one bleed source off the APU, it'll feed both packs, give air to the front of the aircraft, which is left pack, and to the back of the aircraft, which is right pack, air-conditioned air. So that's off right now because APU's off. The engine bleeds are open, even though they're not running. We leave them open. You're going to set your cruise altitude up here. This is the pressurization panel. Then down here is your landing field elevation. So we'll set that for landing field elevation. Whatever our filed cruise altitude is, we'll set there. And then across here, we have manual pressurization. If we lose the auto mode, then we can open and close the outflow valve, which is depicted on this gauge, and pressurize or depressurize the aircraft as needed. This is in the auto mode right now for the pressurization. That's a normal mode for it. And then if we needed to switch it via procedure, we could do that and then control it manually. We have the pressure gauge right here for the cabin. So you can't really see it here, but there are two needles. There is the long needle is going to give you your PSI in the cabin, and the small needle is going to give the cabin altitude. And then we have a cabin rate of climb right here. So that should be 0. These, depending upon, this should be 0, the big needle, because you have 0 PSI, and the little needle, depending upon where you're at, may be higher or lower. We're in Texas, 600 feet. That's pretty close to 0. So when we come down, we're going to look at the mag compass, make sure there's enough fluid in there. The heading makes sense. We got a card on the center post there that's going to give us any magnetic variations that we need, corrections we need to make for the card, given specified electrical conditions, APU generator on, batteries on, no electricity. It gives various configurations there for that. So then we come down, you can see here we have what's called the 6-pack, and that gives us the lights, the panels above us. It gives us an alert that some amber lights are on these panels above us, and then it just tells you, and there's 6 on the first officer's side that are kind of associated with these panels here, and then this overhead panel back here, and then on the captain's side, it's these panels here and these panels here. They actually kind of line up with the different messages. There's just 3 on there right now. So you can cancel that with the master caution, and then you have that cleared out. This is a control panel for the display control panel. This controls the captain's PFD and MFD. And then that one over there controls the first officer's PFD and MFD. So we would set that up as desired, go through all the different buttons and set it up. Across here, we have the mode control panel, which gives us information for our flight director, and ultimately that information is what our autopilot is going to follow. So you have a course, and then that's just for your basic like VOR course, which we really don't use much. We're kind of GPS everywhere we go. We will use it principally for ILSs. But we still like to set that for whatever the departure runway heading is going to be. We set the heading for departure runway heading as well. So we'll set first officer, the number 1 and number 2 VOR, basically number 1, number 2 VORs are set to the runway heading. And then if we do need to return to an ILS for the same runway, we already have it set up. And then the heading is set for the runway heading as well. We're going to set the speed for V2. So whatever our V2 speed is, that'll be in our performance, depending on weight. This is a kind of an average figure for it, a normal figure. Auto throttle switch is on. Going to turn on the flight directors for left and right side. Whichever one you turn on first is a master, and you get a little MA that says that it's the master. So the number 1 side is the master right now because I turned it on first. If we had anything programmed into the aircraft, we could do LNAV, VNAV. So that is VNAV, and then that is LNAV. We don't have anything in the box right now, so that's not going to populate anything right now. So I come across, and then we're going to come down to the center panel from there. Come across over here, we have a clock. We can set that if the time needs to be set, if it's not in UTC, which is what it should be, Universal Coordinated Time out of Greenwich, or Greenwich, depending upon where you're born. Then we have steering, alternate, and normal mode should be in the guarded normal mode. Come up mode control panels, so we can switch the screens here if we want. We want them in the normal mode, so we got them in the normal mode, the reversion stuff. We can test some lights here, so we test, you're going to get 4 yellow, and then and these are just some additional enunciators, and if you go down you get 2 red and a yellow. We can test all the lights on the aircraft. If I can get this thing to go up, yeah, and then you see we got the Christmas tree. We got all the lights on. So these are just basic incandescent bulbs. So you got to check. There's 2 of them in each, so you got to check and make sure that some aren't burnt out. There's a lot of bulbs up here that can be burnt out. Over here, fuel is you go to reset. It resets the fuel in the computer as far as how much fuel is flowed. So you're going to reset the before flight, and then it goes back to rate, which just gives you the rate indications of fuel flow. We have some engine control information here. It's going to be a normal. If we had something that was broken, we might have to go to a different position and then set that engine information manually, N1 and stuff. But most of that stuff resides in the box. Auto brakes, we're going to go to RTO, which is that downward position there. We shouldn't have an amber light. It'll flash on and turn off in the airplane. In here, it's staying on for whatever reason, but that wouldn't be normal. But RTO means it's set for rejected takeoff. That's what RTO stands for. So if we reject the takeoff above, I believe it's 88 knots, the brakes will come on very, very, very aggressively. They'll go all the way up to the anti-skid to stop the aircraft. Flap gauge should indicate 0 here. It can, if we're in icing conditions, previous crew flew through icing conditions, it may be left in 15 degrees, just to make sure we don't damage the flap mechanism, but usually that's 0. 3 green for the gear, it's down. We have accumulator pressure gauge. That's a little bit below green. It's supposed to be in green. If we wanted to, we could come and turn on one of the pumps, and then you're going to see this gauge go up into the green. So we can do that if we need to. And we come across, we're going to test the lights on this side as well. Reversionary should be normal. Come across, we're going to check all of the screens. Right now, we don't have, it's not initialized the information here. So set our IRS position is what this says here. So we'll come across GPS position out of the box. It knows what its GPS position should be because it has GPS information. We come up, we set it in here for the inertial reference system, which is within the aircraft, resides in the aircraft. We punch that in, and then eventually we'll get good displays across here when the thing finishes initializing. So there you go, you see it pops up. So that would pretty much be good information. So we got good information on all of those instruments. If we had not checked, we could check the engine and engine oil quantities down here, and then we can check the hydraulic system as well. But since we already checked that, we don't have to do that again. All right, when we come across, we're going to check and make sure that these are all ground proximity and flap switches. They're associated with the ground proximity warning system. There's several different components in there. Make sure those are guarded. Come here, make sure that the speed brake is retracted. That's retracted. The thrust reversers are both stowed. They're stowed. Flaps are in whatever indication they're supposed to be. 0, 0. That looks good. Parking brakes on. Engine start-stop switches are in the stop position. The stab cutout, and this is actually, if you are familiar with the MAX accidents, the 737 MAX accidents, this is one of the things that had the pilots turn this off, they would have survived, but their procedure was, they hadn't really specified cleanly to pilots that it was a procedure they needed to be really, really, really focused on. But these are the cutout, the stabilizer cutout switches. So they should be in the normal guarded position. There's little guards beneath them. We can do a fire test. So you're going to get all the red lights there illuminate, the wheel well red, and then 2 engine overheats. You're going to get a fire bell, and then you're also going to get master warning, fire warning, master caution, overheat on the panel. That's a good test. We go to the other side, we're going to get a fault APU detect in-op light, and then we get master caution and overheat. So those are good tests. And we're going to come over here. We're going to test the green lights over here. So you get 3 green. There's 2 different channels. You check on that. You get 3 green. That means that you have extinguishers for both engines and the APU. These are extinguishers too in the cargo. So you test that. And again, you're going to get the fire bell. You're going to get 2 red and then amber lights. You're going to get 2 green. And then you're going to get the fire bell on the panel. They show this as in-op for the sim. This is actually the weather radar panel. I just did something recently on this. So this is where the weather radar panel is on the aircraft. If we're going to go into weather, we could test that. It would show some color bands across the MFDs where the weather radar would show that. And then there's what's called a PWS, which is predictive wind shear. And then it'll give you some alerts, wind shear alerts. So you can test both of those if you're going to go into conditions where you think you need them. And then they're kind of missing a few panels back here. So there's another couple of panels. We have a takeoff configuration check button back here that we're going to push. We have a door panel over here that we're going to check as well. We have these trims that we're going to check. So you got rudder trim, you'll check it both ways. Aileron trims, you check it both ways. You have to turn on one of the hydraulic pumps In order to do that, which generally the B hydraulic pump, and then you push, and then you see that this little arrow down here moves as you push, and you bring it back to 0. And then you do the ailerons, and you'll see the ailerons actually move over there as you do in different positions, and then you put them back to 0. And then we'll turn that B pump off. We use the B pump there because the A pump is connected to the nose gear steering. There's a disconnect pin that actually physically goes into the nose gear that disrupts hydraulic power to nose gear, so it's not turning when they got the tug hooked up there, so you're not breaking tow bars and causing damage to the aircraft. That's off the A system when it's in the normal configuration, and the alternate configuration for steering would be under the B system. So the normal configuration, we'll use the B pump when we're doing this stuff, so that we don't potentially, if we push this thing by accident, which is the steering, we don't break tow bars or hurt people or whip whip tugs around. Some of the tugs are a little bit smaller. So that is that's that. We'd be into the box from here. We'd put in some initial information, and we come here to route. This is usually where we'll start in the fleet that I operate. It was flight plan request. It'll actually send it the information through what we call ACARS, which is just sort of a text messaging or radio text messaging service. We'll send a message, say, hey, I'm this airplane, whatever airplane I am here, November 736 Papa Mike. That's who I am, November 736 Papa Mike. You should know what flight plan I want. It talks to the airline, and then it'll send me all of that. It'll populate all that automatically. But if it's not working, you got to hand jam it. So we're in DFW. We're going to put KDFW in here as the origin, and then we'll put KOKC, say we're going to Oklahoma City, and put a flight number, ABC Airlines 123. Not very imaginative, but we got an airplane in there, and we put a runway out of Dallas. We're going to be going off of 17 right. Let's take that in there, and then now we have that information. Doing it ref, let's see, 0 fuel weight. Let's call it 100. This is actually a 737-600 is what this sim is. So it's kind of a low value compared to the 800s that I fly or the Maxes. Reserves, this is just when it's going to alert you. It says, hey, if you're getting to your destination or your alternate, if you have an alternate, you don't have at least whatever you put in here, 5,000 pounds is what I put in there, then it's going to give you alerts down here that says, hey, you have insufficient fuel. So that's just alerting system. Cruise altitude, whatever, we'll put 190. So we're going up to 19 on the way there. 190 comes in. Go to N1. This is going to be the engine mode and limit for takeoff. So a lot of times you'll do derated takeoffs, which means you're not max power off the engines just because you don't need it. Dallas, 13,000 foot runway. You don't need to be using all of the engine, so it preserves the engine. N1 setting here, they have outside air temperature. SEL is assumed temperature, which just further derates. If you say it's hotter than it actually is, it actually drops that N1 number even lower, so you produce less wear on the engine when you take off. Go over to the takeoff page, flaps. We'll say we're taking off with flaps 1 here. CG, we'd get that off of our performance information. We get a closeout. It's printed or on the iPad, and that gives us that information. All of this will auto-download as well for the company I work for. They do have speeds in the box that are calculated. If you go to the next page, you can put runway, wind, whether it's dry, wet, or skid resistant. So wet would be ungrooved wet, and then skid resistant would be grooved wet runway. Runway slope, heading, and then it has that temperature information you put in there. So when you come back to takeoff, once those numbers are all put in, you can just put those speeds in there. And then on the next page, you also have your acceleration altitude, acceleration height. So for single engine work, you have an engine out acceleration altitude, which is this EO acceleration height. And then you have regular acceleration height for 2 engine, and then thrust reduction, which are usually the same. For us, we use 1,000 for everything that's pre-programmed in. Every once in a while that changes a little bit, but it's usually 1,000 feet for the company that I currently work for. And then that's it. As far as that goes, we can stick in a quick route here. Say we're doing the Bleco Zima transition off of 17 right. I killed the takeoff speeds because it thinks that I changed the runway even though I didn't, but that happens. Go to route, we're going to activate that, we're going to execute it so it's in the box. Go departure arrival into Oklahoma City. Arrival, we're going to do Tisdale to 35 right. Stick that in there. We can stick in the ILS to 35 right while we're at it. And I'm not going to use a transition. Execute that. And then you go through legs page and you can cycle through this. We'll drag Tisdale up so there's no discontinuity. And then we got the route in there. And then if we come over here, let's see, get this thing to the right. Right, so then we can step through it. So we can get to legs. You can see here's the airplane, here's the airport, here's the runway. And then we can just start stepping through the route. And then we can just verify those points are good. And they're going to take us up to Oklahoma City, which is our goal for today. So that's all in the box. And then from there, it's kind of sitting around waiting for them to finish boarding the passengers. I get LNAV, VNAV on now that I have some information up there. Let me get the takeoff speeds because it dumped those. And one limit, takeoff. Bang, bang, bang. Oh, I should have VNAV. Yeah, it's not giving it to us. So we got all that in there. That's kind of the high and lows of what you have to set up prior to pushing back. From here, there's your passenger's going to come on board. Flight attendants are going to talk to you. They're going to let you know if there's any service items they don't need. We need water. We need napkins. We need plastic cups. Fuelers, you're going to pay attention to that. See when the fuelers get on board. Start the APU at some point. So we have that is center tank fuel, left and right tank. So a center tank fuel, we're going to feed off of the left center tank pump. If we didn't have any center tank fuel, we'd go off the left forward pump for the APU. And then from there, it's just APU switch on, then APU switch to start. And then this thing is going to start coming up. And then once it's started, we'll get a generator indication for the APU, which is right here. And then we can select the APU for the generator source. We can get rid of the ground power, and then we can come over here and we can get the bleed turned on, packs turned on if they weren't already. They're in auto. And then air is going to circulate through the cabin, cool off the passengers, and make everyone happy. So that's it. If you like this, please leave a comment, like, and subscribe. And I'll do some more of these if it seems like something that people enjoy. We'll go into other phases of flight. Actually, we'll take the thing out and fly, shoot some approaches, maybe fly some interesting city pairings, complex city pairings, single engine fires, things of that nature, sort of some of the stuff that we do. I can even take you through what we'd call maneuvers validation, so all the different maneuvers that we do on the flight. So whether you are a flight simmer or just interested in aviation, a private pilot or professional pilot looking to come into 737, this video is for you. Once again, thanks for watching. We'll see you next time.